I'm going to talk for the first half of the presentation and just give some context around why Cambridge are interested in exploring the concept of a digital twin. And then Gemma will talk more broadly about the work that we've been doing with Lee and Tamir, concentrating specifically on the biomedical campus. So the Smart Cambridge programme, we're employed by Cambridgeshire County Council, and we were set up to look at how new and emerging technology and data can help the Cambridge region to address some of the very real challenges that it faces at the moment, particularly looking at things like congestion, constraints around the energy grid, air quality issues, and how we're going to cope with the amount of growth that Cambridge is experiencing. So we know that we've got approximately 33,500 new houses that will be built by 2031, already constraints on the existing infrastructure, and we need to both plan our future infrastructure better, but we also need to operate the infrastructure that we've got in a much more efficient manner. So we've split the programme into three distinct areas. City as a platform, so this is the kind of underpinning data infrastructure and sensors that we need to support both the work that we're doing now, but will be integral to our approach to digital twins as we go forward, as we'll need really good data to underpin our models. Intelligent mobility, so actually how we move citizens and residents around the area. And again, digital twins will be, what we think will be instrumental in that, particularly in helping us to manage both the network, but also the mobility system as a whole. And then new communities and existing communities. So how we can support the development of new communities through planning policy, how we can give planners better tools, and how we can actually take some of the work that we've been doing in the city out to the market towns and villages in Cambridgeshire. So cities are really complex systems. They cover a whole range of areas. So we've got telecom systems, we've got energy systems, waste, water and transport. And the way that we think and plan those systems at the moment is very siloed. But if you take something like the transport system, there are lots of interdependencies in there. So a bus network will interact with a train network, will interact with a signals infrastructure. And actually the transport network and system will also interact with things like the energy system, particularly as we begin to decarbonise transport. So we need to reflect that in the way that we plan and model and operate our infrastructure and start to bring some of these silos together. And that's where we really see digital twins making a real difference. So there are two kinds of digital twins, and this is taken from the Gemini principles. So a dynamic model of an asset with input of current performance data from the physical twin via live data. And we think this is going to have a real role in how we operate our transport network in the future. And then there's a static strategic planning model of a system. So it's about bringing lots of different systems into one environment. And that's where we've been concentrating our effort. So a digital twin, a realistic digital representation of something physical. And what we've been looking at in this project is the biomedical campus. So what do we think will be the role of a city digital twin? And this is the area that we've been concentrating on this project. At the moment, we have siloed policy making. So we have transport policies, energy policy, environmental policy, and we plan those things in different silos with big models. What we can't do is very easily model in a very lightweight way the way those things interact. And actually, if we use, say, a transport model, it can take a long time to run the model. It's very complex, and we need specialists to be able to interpret the outputs. What we thought was, if we had a very lightweight model that brought all these different areas together, can policymakers, people who are planning infrastructure, begin to test much more radical scenarios? So actually, instead of saying, okay, we've got congestion on this road, should we dual the road, expand the road capacity? What if we could begin to test things like home working? What if we improved connectivity into that area? Would that make a real difference? So really beginning to test some radical policy options and giving people who are working in an office better tools that they can use very easily and run scenarios very quickly, so they can begin to test multiple scenarios instead of kind of coming up with a solution and then testing it using a model. So we've been concentrated on two areas. So the first one is the digital twin, and trying to understand actually what data sources do we need to run the digital twin, and what data infrastructure do we need to support that. What will be the role of conventional models, and actually how can we put across the top of those conventional models a much more lightweight model to begin to test scenarios? And what other tools do decision makers need? And we need to remember that the people making these decisions won't be data scientists. What they need are tools that can easily interpret data and allow them to draw intelligence out of it. And because we'll be bringing multiple city systems together, we need to think about the governance of that. So as a city, there will be digital twins that we own, but it will be a federated model. So we may be bringing in water digital twins, energy digital twins, which we don't own and operate. What will be the governance model that sits over that? How will we share things like intelligence and IP that come out of it? And data sharing and security. So as we're collecting and using data, we need to think about the ethics of that and also the security of the data. So cyber security will need to be embedded in everything that we do. And how can we begin to use this new approach to better engage residents? How can we get residents engaged in the development of digital twins and actually using them? So how can we devolve decision-making down to residents? And also the legislative regulation and policy frameworks and the risk management frameworks that would be needed to support our digital twin. So we're trying to put all of that into a strategy at the moment, and that's part of our work, and that will guide our roadmap in developing a city-scale digital twin. So we're starting small on the biomedical campus, but our overall ambition will be to create something at the city scale and trying to understand what that looks like. Well, it's unlikely that that would be one model, but how do we begin to federate all the digital twins that we may need into one working environment? And I'll now hand over to Gemma, who'll be talking about the project itself.
Thanks, Dan. Yeah, so as Dan's outlined in that summary, we as a county council are keen to understand what the value of the concept for the digital twins can bring for the local authority. And as Jennifer mentioned earlier, we did start some work on this back in 2019. So we brought together some of the local authority stakeholders and mapped the key policy areas that those teams were working on so we could understand where the value might be in bringing the systems together. So this meant that our initial work focused on the way congestion, air quality, energy and local planning policies could, or should at least, interact. So we modelled scenarios to demonstrate the impact of positive policy outcome in one of those domains on the policies of another, by collating a list of data sources. Can you flick the slide on that?
Yeah, sure.
So the modelled scenarios that we focused on were initially around remote working, more relevant today than it was even then, and also around the use of electric vehicles. So for remote working, the calculation assumed that by 2051, at least 14% of the jobs in Cambridge could be conducted remotely, and that these were mostly medium to high skilled jobs which didn't require specialist machinery. By looking at this against the locations that people were doing these jobs and where they travelled from, we were able to see what remote working would mean for traffic volumes on specific routes, and also that we could use that information to determine where as a council we should focus our efforts to encourage modal shift and or shifts in working patterns to give a positive net impact to the flow of our network in the city. On the next slide, Dan. For electric vehicles, we also know that reducing carbon emissions is one of the top policies that are in place at the moment for a number of councils, including ourselves. So shifts to electric vehicles are obviously encouraged, but we wanted to understand what impact that would have. So assuming a shift to all vehicles being electric in 2051, it was likely to support policies on air quality, but it's likely to have a significant impact on the capacity of the energy grid, which in Cambridge is already nearing capacity. So the model on the right-hand side of the screen demonstrated that if all electric vehicles were charged at the workplace, so based on the work information that we had previously, the grids in workplace centres such as Peterborough and Cambridge would be put under significant strain, whereas if you look at the picture to the right, the far right of the screen, the load is more evenly distributed across locations where people are working from home. So with this information available, we could work as a local authority with businesses to perhaps coordinate measures to encourage employees to charge their vehicles at home and reduce pressure on the grid. I think with the events of recent weeks leading to such a significant move to remote working, energy use and network connectivity will be peaking in different areas. So with things like the digital twin, we may be able to use data from this particular period in the future to better understand how we can support remote working on a larger scale and over a longer term, and the impact that that has for overlapping policies. Next slide. So we completed that work back in the summer of 2019, and then have started some new work, as Dan mentioned earlier, based around the Cambridge Biomedical campus, or the CBC. CBC was selected because it offers a sort of microcosm of the wider challenges that we see in Cambridge. So the site is already home to several multinational companies and research institutions, as well as 3 hospitals. The campus continues to grow, and it's expected that by 2031 there'll be 67,500 trips every day made to that site. So infrastructure for energy, water and transport are all needed to support that growth, but also to try and alleviate the challenges that are already being experienced there on the site. So as a programme, Smart Cambridge want to ensure that we're delivering value through the work that we do, not just a clever piece of technology. So with that in mind, the latest phase of our work with CSIC has been in 2 parts. The first focusing on key stakeholder groups and the potential use cases that each have in relation to a digital twin. And the second focused on what sorts of insights we can draw by bringing together multiple data sets, in this case specifically related to mobility on the CBC site. So in the stakeholder stream, we're looking to identify the use cases and whether there are similarities between those stakeholder groups, and most importantly, is there any use case at all?
Gemma,
so we've
pop in to say you've got 3 minutes.
Oh, okay. Next slide, please, Dan. So we've taken the stakeholder engagement process, identified the groups, and created a list of questions that we are asking, the same questions to each group, so we can compare them. We are looking at some common cases at the moment between particular groups, shown on the right-hand side of the screen, but we are finding that the use cases for residents specifically are quite difficult to clarify, and that's because having a discussion with them about a digital twin without leading them into examples of what it might be useful for is quite difficult. But one common area that we have identified across all the groups we've spoken to so far is that they feel the growth of the CBC site is not well coordinated, and therefore a digital twin type model is likely to help with the coordination and federation of that information. Next slide. So behind the stakeholder work, we've also been looking at an early model which Lee has been building. This has taken sources of data that we already had, so an ANPR number plate recognition survey completed in 2017. We had 100 sensors across the city, and we've located the 3 in the bottom of the screen there in the green circle. We do know that one of those routes did not cover, was not covered, so there is some impact on the data from that. But we've been able to look at that and understand how people are moving around the site, coming in and coming out. If you flip to the next one, then. So this, yeah, put them all on. So across the city, just over 100,000 cars captured. Of those, 16,000 were on the CBC sensors. Of those, on 2 sensors, we located around 7,000. So we've got people that we've then identified based on how long they were on site, whether they were dropping off, whether they were visiting, whether they're part-time workers, commuters, etc. And for those that were only captured once, we've identified around 8,000 vehicles, which we've put down to being part of the nighttime shift work. And that's based on the time that they spend on site. So further insight that we've gained from that is around peak times. So on the next slide, we can see that the peak of vehicles arriving and departing the site on one day is almost equivalent in the morning and the afternoon. So we've been looking at what we can do with this data. So for example, could employers on the site stagger their employee start or possibly finish times? Can you schedule on-site meetings for particular periods to reduce congestion? And for the hospitals, could they schedule appointments during quieter periods and evaluate the appointment times based on how travellers are getting to the hospital? Some of these are quite radical proposals. So as Dan mentioned earlier, the ability to look at this through a lightweight model is quite significant for us, so that we can decide what might make a significant impact and therefore should be modelled in greater detail.
That's
Next
15
slide.
minutes, Gemma. If you could just
Okay.
wrap up. Thanks.
Yes, okay. I think this is probably the final point then. We've also identified that there are quite a few areas where we've got a rich data set, but we could enhance that by adding a further rich data set, such as in this case, more information on travel for work, which should give us the opportunity to verify some of our findings, but also build greater insight. So we're looking at network management and air quality, and as we move forward with this project, that's what we hope to achieve. So I think that's probably the wrap up really. Yeah, basically the proving of the lightweight digital twin gives us a strong platform that we can scale up a solution on afterwards and aim to offer tangible benefits both to our residents and our own local authority partners.